Okay, welcome. Today we are looking at Chapter 6, Topic 4, which is simplifying radicals. Okay, so a radical looks like this. This is the radical symbol. Every radical has what is called an index. In this case, the index is n. It's just a placeholder for a number. A lot of times you see a radical that doesn't have an index written down, which case you assume that the index is 2 and that you're taking a square root. However, the index does not have to be 2. Sometimes you could have 3, which would be a cubed root. You could have 4. You can really have any integer, well, not integer, but any natural number for your index. What the index tells us when you're taking a square root of something or a cubed root of something, a number in particular, or not even a number, a value. The index tells you how many of a certain factor you need before you can bring one of those numbers to the outside of the radical. So in the case of a cubed root here, we would be looking for 3 of the same factor. We need 3 of the exact same factor underneath the radical symbol so that we can bring that number to the outside of the radical symbol. So for instance, like when you're taking the cubed root of 8, okay, well the cubed root of 8 is 2 because the number 8 is made up of 3 of the same factor, 2, 2, and 2. This is 3 of the same factor. There's 3 2's. 3 factors of 2 that make up the number 8. So that would mean that the cubed root of 8 is equal to 2. That means you can take those 2's out of the radical and make a single 2 on the outside, and there would be nothing left under the radical, meaning the cubed root of 8 is equal to 2. If we look at some examples here, we have the square root of 24. The index of this one is 2. Since it's not written here, the index is 2. So we're looking for 2 of the same factor that we can take out of 24. Well, 24 can be split up in a lot of different ways. Okay, 12 times 2, 3 times 8. But we want to split it up so that 2 of the same factors are a part of it. Well, you can't do that using just 2 numbers, but I could split this up into 8 times 3, and then split that 8 into 4 times 2, and then split that 4 into 2 times 2. So you see, 24 is made up of 2 factors of 2, and then a factor of 2 and a factor of 3. Well, these 2 factors of 2 can actually come out of the radical because we have because we're looking for factors of 2. And that should make sense because 2 times 2 is 4, and the square root of 4 is 2. So a factor of 2 can come outside the radical because there's 2 factors of 2 underneath the radical. And then what's left is just 2 times 3, so we have 6 that's left underneath the radical because you can't take the square root of 6 or any part of it because it's only made up of 2 factors, 2 and 3, and we need 2 of the same factor in order to take a square root. Now look at number 2. We actually have to do this in 2 different parts because we have the square root of 32 x to the 8th. I first need to find out what the square root of 32 is, how to simplify that, and then I need to simplify x to the 8th, the square root. Well, 32 has factors 4 times 4, because 16 is a factor of 32, so 4 times 4. You can split 32 into 16 times 2. And since 16 is made up of 2 factors of 4, 4 times 4, you could take the square root of 16 and take a 4 to the outside. So the square root of 32, 4 on the outside is what we can take out, but there's still a factor of 2 that's left underneath the radical. Okay, so when you're thinking about this, it's easy to it's convenient to think about what what can you take out of the radical and what's left under the radical. So for the square root of 32, you can take a factor of 4 out of the radical, but there's still a factor of 2 that's underneath the radical. Now, when we consider the other part, which is the x to the 8th, x to the 8th, we're looking for two factors that are the same, that are factors of x to the 8th. Well, x to the 8th is simply x to the 4th times x to the 4th. So x to the 8th is made up of two factors that are the same, x to the 4th and x to the 4th. So x to the 8th is just x to the 4th, or the square root of x to the 8th under the radical means we can take x to the 4th outside of the radical. Now there's nothing left underneath the radical, so we're done for this part. Now there's an easy way to do this, to discover how many factors of x you can take out. In this case, we took out 4 factors of x. And all you have to do is divide the exponent by the index. Okay, so when you do 8 divided by 2, you have 4. So that means you can take an x to the 4th out of the radical. So let's put our answers together to create our answer for 32x to the 8th square root. So what were we able to take out of the radical? We were able to take a 4 out of the radical. We were able to take an x to the 4th out of the radical. What was left underneath the radical? The only thing left underneath the radical was a 2. So the square root of 32x to the 8th simplifies to 4x to the 4th times square root of 2. And then number 3, we have the square root of 54x to the 6th, y to the 13th. And once again, I'm going to do this in 3 separate parts. I'm going to do square root of 54. I'm going to do the square root of x to the 6th. And I'm going to do the square root of y to the 13th. In all of these cases, the index is 2, so I'm looking for factors, 2 of the same factor underneath the radical that I can make outside the radical. Now, a factor of 54 is 9, and that's good because 9 is made up of factors 3 and 3. So you can take the square root of 9. So 54 could be 9 times 6. Since 9 is made up of the same two factors, 3 times 3, you could take the square root of 9. Square root of 9 is 3. However, 6 does not have 2 of the same factor, so it is stuck underneath the radical still. So square root of 54 will simplify to 3 times the square root of 6. Now, the square root of x to the 6th, I said there's an easy way to do this. You can divide the exponent by the index. So 6 divided by 2 means that we can take 3 factors of x out of this. Okay, because x to the 6th is just x to the 3rd times x to the 3rd. So we can take a factor of x to the 3rd out. So x cubed is the square root of x to the 6th. You just divide 6 by 2. Now, it's a little bit different when it doesn't divide evenly. So you see that y to the 13th, if you divide 13 by 2, it doesn't go into it evenly. It has a remainder. Well, that's actually okay. Okay, any factors, any remainder that you have, that's how many factors you'll have that are still underneath the radical. Okay, so for instance, when you divide 13 by 2, that means you can take 6 y's out because 2 goes into 13 6 times. But that only makes 12. 2 times 6 is 12. But you need a 13th y. Okay, you only have 12 right now. The 13th one is still underneath the radical. That remainder, that means we still have a y that's underneath the radical, the square root of y. So 13 divided by 2 is 6, with a remainder of 1 that's still underneath the radical. So I can put all of this together to simplify number 3. So first let me write what I have on the outside. So I was able to take a 3 out, I was able to take an x cubed out, and I was able to take a y to the 6th out. What I was not able to take out, the factors that are still underneath the radical, is a 6 and a y. So this would be my simplified answer for number 3. 54x to the 6th y to the 13th simplifies to 3x cubed y to the 6th square root of 6y. Now sometimes you will have an index that is not 2. Like for instance, number 4, we have an index of 3. We have the cubed root of 24. A cubed root, this no longer means we're looking for 2 of the same factor. We are now looking for 3 of the same factor. Okay, so we need numbers that are factors of 24 that are made up of 3 of the same factor. Well, I know that 8 is a factor of 24. 8 goes into 24. And 8 is made up of 3 factors of 2. 2 times 2 times 2 will make 8. So 8 will be a factor that I can take a cubed root of. 24 is just 8 times 3. And the cubed root of 8 is 2. So 2 can come out, and that 3 is still stuck underneath the cubed root symbol. So that's all we had to simplify for that one. So the cubed root of 24 simplifies to 2 times the cubed root of 3. Number 5, we have the cubed root of 125, x to the 7th, y to the 9th. Okay, so once again, I'm going to do this in 3 separate steps. For each part of this, I'm going to simplify the cubed root of 125. I'm going to simplify the cubed root of x to the 7th. And I'm going to simplify the cubed root of y to the 9th. Well, the cubed root of 125 is actually made up of 3 factors of 5, 5 times 5 times 5. So the cubed root of 125 is just 5. The cubed root of x to the 7th. Now, if you divide the exponent by the index, 7 divided by 3, 3 goes into 7 2 times. So you can take 2 factors of x out of the radical. However, there is going to be a remainder. Okay, 3 goes into 7 2 times, but that only makes 6. We have a remainder of 1, so that means we still have a single x that is underneath the radical. So 2 x's come out to make x squared, 2 factors, and we have a single factor of x stuck underneath the radical. And then for the last part, the cubed root of y to the 9th, 3 goes into 9 evenly, it goes in 3 times, so you can take a factor of 3 out of the radical. And there's 3 factors of y out of the radical, and there's no remainders, so there's no y's left underneath the radical. So if I put all of this together, what was I able to take out? I was able to take out a 5, I was able to take out an x squared, and I was able to take out a y cubed. What was I not able to take out? The only thing left underneath was an x. So almost everything came out. The only thing that didn't come out was one of the x's. One of the x's is stuck underneath the radical. All right, and then number 6, we actually have a 4th root here, 32x to the 10th, y to the 12th, z to the 9th, and this just means we are now taking out 4 of the same factor. So 4 of the same factor. So 4th root of 32, 4th root of x to the 10th, 4th root of y to the 12th, and the 4th root of z to the 9th. Is that z to the 9th? Yeah. Okay, so as we can see here, so when we're looking for the 4th root of 32, we're looking for a factor of 32 that's made up of 4 of the same factors, so a perfect fourth, apparently, which is 16. 2 times 2 times 2 times 2 is 16. So 16 is made up of 4 of the same factors. So the 4th root of 32 could be written as the 4th root of 16 times 2. And you can take the 4th root of 16, that's just 2. So you can take a 2 outside, but you're stuck with a 2 underneath the radical. X to the 10th, the index goes into the exponent 2 times, so you can take 2 factors of x out, but you will have a remainder because 4 goes into 10 to make 8. You still have 2 x's left over, so those 2 x's are still underneath the radical. For y to the 12th, 4 goes into 12 evenly. It goes in 3 times, so you can take out y cubed. And then z to the ninth, 4 goes into 9 two times, so you can take out two factors of z. However, there's still a remainder, so there's still a factor of z that's left underneath the radical. So our final answer, what were we able to take out? We were able to take out a 2, we were able to take out an x squared, we were able to take out a y cubed, we were able to take out a z squared. What were we not able to take out? What is left under the radical symbol? A 2, an x squared, a factor of x squared, and a factor of z. So this is the simplified version of number 6. The fourth root of 32x to the 10th y 12th z to the 9th is 2x squared y cubed z squared, and times the fourth root of 2x squared z.